Welcome back to Coffeesodes, everybody. I'm Josh. This is episode 43, and we are diving deep into some seriously intriguing research about some pretty bizarre things happening way up above us in Earth's atmosphere.
Sounds fun.
If you want to check out the research for yourself, the links are down in the episode description.
Definitely.
So are you ready to explore some anomalies that have scientists scratching their heads?
Always.
Okay, let's get started.
Let's do it.
Let's start with these strange temperature spikes that show up in the stratosphere every year.
Okay.
We're talking about spikes in December and January at altitudes where the temperature should be dropping. It's pretty weird, right?
Yeah.
What makes this even more interesting is that the total electron content, or TEC, of the atmosphere is also jumping around in ways that don't seem to be caused by the sun.
Yeah, and TEC measures the ionization levels in the atmosphere, so these jumps suggest something unusual is happening up there.
Here's where things get really wild. These TEC anomalies appear to be linked to earthquakes.
Really?
You heard that right? Earthquakes.
It's true, and what's fascinating is that we're seeing this connection between seemingly disparate phenomena, temperature fluctuations in the stratosphere, changes in ionization levels, and seismic activity. It suggests something much larger is at play.
Like what?
Possibly a kind of streaming invisible matter flowing through our solar system.
Okay, so we've got these mysterious anomalies, and scientists are proposing some pretty out-there explanations.
Right.
One of those explanations involves something called axion quark nuggets, or AQNs. I'm guessing this is where the deep dive begins.
Absolutely. AQNs are theoretical particles that are incredibly dense and tiny, composed of quarks and antiquarks surrounded by an axion field.
So the fundamental building blocks of matter and antimatter all bundled up together.
What makes them really interesting is that they're thought to be cosmologically dark in space, meaning they don't interact much with normal matter. But when they encounter a dense environment like a planet or a star,
They become more noticeable.
exactly, their interaction with matter increases significantly.
All right, I'm intrigued. So let's say these AQNs are zipping through space and they collide with Earth. What happens then?
Well, as they travel through the Earth, they would interact with matter and heat up, releasing a tremendous amount of energy, primarily as a specific type of radiation called Bremsstrahlung radiation.
Okay. And how would we detect this radiation? What would the effects be?
This radiation would be in the form of EUV and X-rays. That's pretty powerful stuff. And we believe these emissions from AQN annihilation could be ionizing the atmosphere, causing those TEC jumps we were talking about.
Hold on. So you're saying these tiny AQNs could be responsible for those strange temperature spikes in the stratosphere too? That's wild. I'm starting to see how the pieces fit together.
You're getting it. As these AQNs pass through the atmosphere and collide with particles, they deposit energy which could lead to localized heating, especially in the stratosphere.
Wow. And what about the earthquake connection? Could AQNs explain that too?
It's possible. Think about it. If these AQNs are dense enough, they could generate shock waves as they plow through the Earth. These shock waves might be strong enough to trigger earthquakes in areas where there's already a buildup of geological stress.
Okay, this is blowing my mind. But how do we know that these events aren't just random? What evidence is there to suggest that AQNs are actually involved?
That's a great question. And that brings us to perhaps the most fascinating piece of this puzzle, the planetary correlations. Researchers have found some intriguing links between these atmospheric anomalies and the positions of planets in our solar system.
Wait, what? You're telling me that the positions of Jupiter and Saturn could influence the occurrence of earthquakes here on Earth?
It sounds crazy, right?
Right.
But that's what the research suggests. It seems that the alignment of planets could actually influence the flow of these hypothetical AQNs.
Okay, now I really need to hear more about this. How could something like that even work?
Well, to understand that, we need to dig a little deeper into the properties of AQNs themselves and how they might interact with gravity on a cosmic scale.
This is incredible. I can't wait to hear more.
So before we were talking about the possibility that axion quark nuggets,
Right.
these tiny dense particles could be responsible for some really puzzling anomalies in Earth's atmosphere.
And we were just about to delve into the planetary correlations.
Yeah.
It's just mind-boggling to me that the positions of planets could somehow be related to these AQNs hitting Earth.
I know, it's pretty wild. But let's back up for a second and talk about what makes AQNs so unique compared to other dark matter candidates like WIMPs, or weakly interacting massive particles.
Yeah, I've heard of WIMPs. They've been the front runner in the dark matter search for quite a while, haven't they?
That's right. But WIMPs, as their name suggests, interact very weakly with normal matter. This makes them incredibly difficult to detect directly.
So AQNs are different in that they interact more strongly.
Exactly. They're made of quarks and gluons, the same stuff as the visible matter we see around us. But here's the key difference. They act like chameleons. In the vast emptiness of space, they're cosmologically dark, meaning they barely interact at all. But when they encounter a dense environment, like inside a planet, their interaction with matter increases dramatically.
And so they kind of wake up when they encounter something substantial.
That's a great way to put it. And when an antimatter AQN collides with normal matter, it annihilates, releasing a tremendous amount of energy.
Okay, so I think I'm starting to wrap my head around that part. But what about the structure of AQNs themselves? You mentioned earlier that they have an axion field surrounding them. What role does that play?
The axion field is crucial for the stability of AQNs. These things are unbelievably dense. Imagine squeezing 1 billion tons of matter into something the size of a speck of dust.
Wow, that's just incomprehensible.
Right. To prevent these incredibly dense objects from just flying apart, you need something to hold them together.
Right.
Something to provide a sort of inward pressure. And that's where the axion field comes in.
So the axion field acts like a glue that keeps the AQN from disintegrating.
Exactly. It's what makes them so stable.
Yeah.
And this axion component is also what allows AQNs to be cosmologically dark in space. It essentially shields them from most interactions. But as we discussed earlier, when they encounter a dense environment, that shield drops and the fireworks begin.
All right, that makes sense. But if these AQNs are so dense, how do they even travel through the Earth without getting stuck? Wouldn't they just collide with something and stop?
That's where their incredibly small size comes in. AQNs are on the order of micrometers, which is tiny even compared to the spaces between atoms. Their small size combined with their high density allows them to pass through matter relatively unimpeded.
So they slick through the gaps in matter like tiny, dense ghosts.
You could say that. But it's important to remember that while AQNs are thought to be abundant in the universe, their interactions with Earth are statistically rare. We're not talking about a constant bombardment, more like occasional isolated events.
So we're lucky to even detect these events at all.
In a way, yes. These subtle but persistent anomalies in Earth's atmosphere might be our only glimpse into this fascinating and potentially game-changing realm of dark matter physics. But now I think it's time we finally tackled those planetary correlations.
Yes, let's get to the really weird part. Okay, so we've covered a lot of ground here.
Yeah.
We talked about axion quark nuggets,
Right.
These tiny, super dense particles that could be zipping through space, and even our planet.
Yeah.
We've talked about how they might explain some of the bizarre things happening in Earth's atmosphere.
Like temperature spikes in the stratosphere,
Yeah.
strange jumps in the ionization levels,
Right.
even a possible link to earthquakes.
But the part that's really got me hooked is this idea that the positions of planets in our solar system
Yeah.
might actually be influencing these AQN events. I mean, how is that even possible? It sounds like something out of science fiction.
It does sound far-fetched, but the math and physics behind it are quite compelling. It all comes down to gravity. Remember, we're talking about AQNs as part of this streaming invisible matter that's flowing through our solar system. As these AQNs pass by massive objects like planets, their paths can be bent and focused by gravitational forces.
So the planets are acting like giant lenses, focusing these AQN streams towards Earth.
That's a good way to think about it. And of course, the strength of this gravitational focusing would change over time depending on where the planets are in their orbits.
Which would explain why we see these anomalies happening more frequently at certain times of year. When the planetary alignment is just right, it's like Earth is passing through a concentrated beam of AQNs.
Exactly. And that brings us back to those specific anomalies we've been discussing. Those temperature spikes in the stratosphere, for example, could be caused by a higher concentration of AQNs depositing their energy as they pass through.
And what about those tech jumps? How does the planetary alignment factor into that?
Well, remember that when an AQN annihilates with normal matter, it releases a lot of energy as EUV and X-ray radiation. And this radiation can ionize the atmosphere, causing those jumps in tech. So again, if the planets are focusing more AQNs towards Earth, we would expect to see a corresponding increase in tech during those times.
Okay, that makes sense. And I guess the same logic applies to the earthquake connection. If there's a greater flux of AQNs passing through Earth due to planetary alignment, there's a higher chance of those shock waves triggering seismic activity.
Precisely. It all ties together beautifully, doesn't it?
It's amazing.
Yeah.
But it's also kind of unsettling, isn't it, to think that these invisible particles, guided by the gravitational pull of distant planets, could be having such a profound impact on our planet.
It is a humbling thought, isn't it? It reminds us just how interconnected everything in the universe really is. We often think of space as this vast, empty void, but it's actually teeming with invisible forces and particles that can have a very real impact on our lives.
This whole AQN model is just so mind-blowing. If it turns out to be true, it would revolutionize our understanding of dark matter and its role in the universe. It might even have implications for things like earthquake prediction or maybe even harnessing the energy of these AQNs someday.
It sounds like science fiction, but who knows? The universe is full of surprises.
Absolutely. Well, I think we've given our listeners a lot to think about today.
Cheers to that.
Cheers. Thanks for joining us on this deep dive, everyone. Until next time.